Yes, this video is on design of experiments pioneered by R.A. Fisher. The designs are developed in such a way that the experimental error are reduced. As many explanatory factors are included and experimental errors are reduced. Okay, what is experimental error? The error due to random or chance cause or non-assignable cause, right, is called an experimental error. The error which is due to random cause, chance cause or non-assignable cause, which cannot be avoided, which cannot be controlled, is called experimental error. And this fact we know that the variance of a statistic, the reciprocal of it is the precision. Suppose that you have two designs D1 and D2. The efficiency of the design D1 with respect to D2 is we are familiar with this concept with the theory of estimation. There we find the efficiency of an estimator with respect to the minimum variance unbiased estimator as variance of minimum variance unbiased estimator divided by the variance of the estimator for which the efficiency is computed. Similarly, efficiency of a design D1 with respect to D2 is variance of D2 divided by variance of D1. This is the design for which you are calculating the efficiency, and the variance of that design should appear in the denominator. And you know the variance, the formula is this 2. For design 2, we represent it as sigma 2 square by R2. R2 is the number of replicates. 2 sigma 1 square by R1. And this is the formula. If E is equal to 1, you should come to the conclusion that both D1 and D2 are equally efficient. But if E is greater than 1, you can say that D1 is efficient than D2. Okay. Right. Uniformity trials. You perform the trials on the experimental units which are divided into homogeneous plots. Right? They are called uniformity trials. This is done to improve the efficiency of the design. And this gives a graphic picture of the variation in soil fertility. And this graphic picture is called fertility contour map. Okay. The percentage standard error to which the mean effect of a treatment which is replicated R times is, what is the percentage of standard error? See, this is the standard error divided by the statistic into 100. X bar is the statistic whose standard error is sigma by square root of n. Right? Had it been 100, what would have been the standard error? So, which is sigma by x bar into 100 into 1 by root n. This is nothing but the formula for coefficient of variation. So, the formula is coefficient of variation divided by square root of n. Okay. Now, in a CRD with T treatments and n experimental units, what will be the degrees of freedom for various components? For the total sum of square, you have n minus 1. You have n experimental units. Since you have T treatments, the degrees of freedom for treatment sum of square is T minus 1. And for error, it will be total minus treatment, which is n minus 1 minus T plus 1. That is equal to n minus T. Right? In RBD with T treatments and R replicates, the treatment sum of square is T minus 1. The block sum of square or replicate sum of square is R minus 1. Total number of experimental units is T treatments, R, every treatment is repeated R times, so RT minus 1. The error degrees of freedom is RT minus 1 minus T minus 1 minus R minus 1 minus T plus 1 minus R plus 1. 1 gets cancelled. So you have RT minus T minus R plus 1. Out of these two terms, take t as the common term, you get r minus 1. And out of these two terms, take minus 1 as the common term, you get r minus 1. So it is r minus 1 into t minus 1, the error degrees of freedom. And the efficiency of RBD relative to CRD, this is the expression which is derived. Okay, fine. Suppose that you have an LSD with two treatments. How many standard squares exist? What do you mean by standard squares? The alphabetic order AB and AB should be there in the first column and second column. The arrangement in alphabetic order in the first row and first column. First row and first column. So this is the only possibility. So you have only one square, one standard square exists. Consider three treatments. Have the treatments in alphabetic order in the first row and in the first column. So for the remaining place, this is the only way with which you can fill, because if you have A, you should put C here. That is not allowed because C occurs for 2 times in C. What I am telling is, okay, for the remaining treatment CA, instead of CA, if you put A here and C here, what happens? C will appear for 2 times in the third column, which is not allowed, right? In every row and in every column, you should have every treatment occurring only once. So this is the only possible arrangement. So only one standard square of order 3 by 3 exists. If you have 4 treatments, you have 4 standard squares. Okay, you can have 4 standard squares. You can check this. In the second row, A, B, C, D appears only for one time. See in the second column, in the third column, nothing is repeated. Okay, right. So the total number of LSDs of order M. What is the total number? How to compute it? The formula is m factorial into m minus 1 factorial into number of standard squares. You may have problems based on this formula. Okay, and in an ANOVA, the number of rows, the number of treatments in the row is m, so the degrees of freedom is m minus 1. The number of treatments in column is also m, so m minus 1. The number of treatments is m, so m minus 1. Total number of observations is m cross m, that is m square minus 1. So the error sum of square is m square minus 1 minus this m minus 1, this m minus 1, this m minus 1. Right, so m square minus 1 minus 3 times of m minus 1. So m square minus 1 minus 3m plus 1. Right, so minus m plus 1, I have multiplied. 1 and 1 gets cancelled. That's also I have m square minus 2m minus 3m plus 2. On factorizing, I get m square minus 2m minus m plus 2. So I get m into m minus 2 minus 1 into m minus 2. That is m minus 2 into m minus 1. Okay. So that is the answer I have here. The error degrees of freedom is m minus 1 into m minus 2 for LSD. Okay, fine. Now, based on this, let us discuss today's questions. Which of the following is false about experimental error? It is a variation due to random causes. It is true. It is a variation due to assignable causes. No, it is false. It is a variation due to non-assignable causes. It is true. It cannot be controlled. It is true. So this alone is false. The reciprocal of variance is an index for precision of a statistic. If the efficiency of a design D1 with respect to D2, which is represented as E, is greater than 1, efficiency of D1 which is denoted as E is greater than 1, D1 is efficient than D2. The graphic picture of variation in soil fertility is given by fertility gradient map, fertility contour map, fertility descent map, contour descent map. It is fertility contour map. Okay.